All right, we'll go real quick. We got piperin. This is in right here. Piperin. This is a compound in pepper. You can see there's a lot of carbons, nitrogen, some oxygens, as well as hydrogen. And then beta carotene is actually pretty long. It forms vitamin A. And so you can see it's a pretty big compound. We're going to be working with some larger ones like this. This is strictly just carbon and hydrogen, and that's it. This would be considered an alkene because you can see there are double bonds in there. All right, so here we go, functional groups. This is stuff that's other than carbon or hydrogen, all right? So whenever you see an R, that just means it can be any number of carbons. It doesn't matter how many. It could be 1, it could be 50, it doesn't matter. And so here, alcohol is just R, it's an OH at the end. These are pretty common. Ethers are a carbon chain, then there's an oxygen, and then there's another carbon chain. It's an ether. Amines are carbon attached to a nitrogen. There could be 3 carbons attached to this nitrogen. There could be 1. We'll talk about those primary, secondary, tertiary amines. Thiols are much like alcohols in that there's an SH there. An aldehyde is a carbon chain, and this C double bonded to an O with another H. They're kind of smelly. Ketones, carbon chain, then a carbon with a double bond oxygen, then another carbon chain. Carboxylic acid, we sort of talked about those already, COOH. Amino acids, these are super duper important. We have R, carbon chain, then CH with an NH2 branching, and then your acid groups. So we're starting to get a little more complicated. And then amides are carbon chain, then carbon double bonded to oxygen, and this carbon's bonded to a nitrogen, which has an R group and an R prime group, and that is really important for protein synthesis. Like that's how they're put together. So here we have ethanol. I just put some in here. Diethyl ether, ammonia. It's going to be an amine. Grapefruit mercaptan. That's a thiol. If you're wondering what that's in, well, you should probably figure it out. Cinnamaldehyde. Hopefully you know what that's in as well. This is going to be our aldehyde down here. This is cinnamon. Acetones, nail polish remover. It's ketone. Ethanoic acid or acetic acid. That's in vinegar. Beta alanine, if you ever take some pre-workout and you feel like your face is melting, that's what stuff's doing. And there's your acid. Phenylalanine is an amino acid, amine group. And then lactic acid. That's just another acid group there. That's also got an alcohol group. We all know lactic acid if you have sore muscles after working out. So here, slide 8, polarity and solubility. Does it dissolve in water or fat? This is kind of a big deal because we have to understand if vitamins are drugs and pollutants are fat or water soluble. All right, pretty simple. Polar, then it dissolves in water. If it's non-polar, then it dissolves in fat. And it's pretty simple. If it has an OH group, OH, like an alcohol, and it has 5 or less carbons, it will dissolve in water. If it has 6 or more carbons, nope, it's going to be fat soluble. That's what we're looking at here. Salt, ascorbic acid, and ethanol is all dissolved in water, whereas cholesterol, vitamin D, those are fat soluble. These are just some pollutants. I'm going to finish this off on the next video, which shouldn't take too